For our first example, we're going to look at the function f of x equals x plus 2 cubed minus 3. So here are instructions. First, we're going to list in a correct order the transformations that have taken place in the parent graph of this function in order to result in this given function. So let's do that first. So we're going to look at the equation and see how this is different from its parent function. So first we have to identify its parent function. So all you can do is cover up all the numbers, cover up the -3, cover up the 2, and if you cover those up, you're left with just an x cubed. So our parent function is x cubed. Okay, so I'm going to look inside my grouping symbol. Now notice when you have a cubic function, your grouping symbol here, you've parentheses here. So we're adding 1 inside the parentheses. So that means that we're going to, inside the parentheses, inside the grouping symbols, horizontal. So we have a horizontal shift left 2 units. So remember, when things inside the grouping symbol, horizontal things tend to be backwards. We add 2, we actually go left 2. Then if we look outside the grouping symbol for our vertical changes, we're subtracting 3. So we know that that's going to be a vertical shift down 3 units. Okay, now we want to graph each function using transformations. So when it says using transformations, that specifically means, and I'm going to remind you on quizzes and tests, you want to start with at least 3 points on the parent function and then show the corresponding points on the new graph. And it's really important that you show it exactly the way I'm about to show you here in order to get full credit. Okay, so we identified the parent function as x cubed. So you're going to make a table. So there's the parent function, x cubed. Now here's the new function, x plus 2 cubed minus 3. Okay, so let's perform. So we're going to start with 3 key points, easy points to generate on an x cubed graph. You don't have to memorize them, you can easily generate them. And on all your parent functions, easy key points to plug in, if applicable, would be like -1, 0, and 1. Those are easy points to pick. You don't have to pick those, but those are easy ones if they work. Okay, so I can plug in a -1 into x cubed, so -1 cubed would give me -1. So I've got 1 point here, -1, -1. Then if I plug in a 0 for my x, 0 cubed is 0. So I've got another point on that parent function, 0, 0. And then if I plug in a 1 for my x, 1 cubed is also going to give me 1. So these are my 3, I'm calling them key points, easy points to generate, that'll give us the general shape of that x cubed function. And we should remember that that x cubed function is that snake-looking shape, that increasing snake shape. Okay, so in order to apply these transformations to horizontally shift this function left 2 units, remember, the way that that happened in the equation was by adding 2 to the x's. But again, we're doing opposite. So we're going to take all the x values of these key points and we're going to subtract 2. So you don't have to list this, but I think this is good to write down in your notes. To perform this transformation, you're going to subtract 2 from your x values. Horizontal change, you're changing x values. So for my new points, I like to do them separately, horizontal and then vertical. So I'm going to subtract 2 from all of these x values. So I'm going to take -1 minus 2, and I'll get my -3. And then I'll take my x value here is 0 minus 2, and I'll get -2. And then I'll take my x value here, 1 minus 2, and get -1. So that just shifted these 3 points left 2 units. Now we need to apply our vertical shift. So we know the vertical shift happened because we subtracted 3 outside the grouping symbol, vertical change. So we're going to change our y values. We're going to subtract 3 from our y values. So I've got my -1 here. -1 minus 3 gives me -4. 0 minus 3 gives me -3. And then 1 minus 3 gives me -2. So now, these 3 key points on the original parent function after the 2 shifts have now transformed into these 3 points. So if we plot these 3 points and we know the general shape of an x cubed graph is that snake shape, we can get a good sketch of this graph. Okay, so I got my point -3, 4. Actually, use a different color here. -3, 4. 1, 2, 3. 1, 2, 3, 4. Oh, whoops. -3, -4. 1, 2, 3. 1, 2, 3, 4. And then we've got -2, -3. And we've got -1, -2. And we know that snake shape, that increasing snake shape of an x cubed graph. And make sure that you guys label all these points so that I can grade them most easily on your quizzes and tests. And then we've got our -2, -3, and then we've got -3, -4. Now, you don't have to plot the parent graph on the same axes here, but I think it's nice visual here. If you guys plot these original 3 points from our parent function, so our -1, -1, 0, 0, and 1, 1, we know that general shape of that parent function. So this was our x cubed. And then after those transformations, here's our x plus 2 cubed minus 3. So you can see that our green graph, our parent function, has been shifted left 2 units and down 3 units. So please make sure, I'm going to highlight this, you have to show me this on quizzes and tests. So when I say graph using transformations, you absolutely have to show me everything here. It's super important to remember that. Even if you can get these 3 points, it's important that you use transformations, which means listing the key points first from the parent, and then the way they correspond, the way they're transformed for the new function.